intro. It's been actually a wild ride. Yes, for those I haven't met, I'm Paul Davies. I'm a technical fellow at the Boeing Company. I'm in the research and technology group. I actually started working in AR 18 years ago. And when I think back, I'm like, where has all that time gone? I'm like, 18 years, like, what have I done for 18 years? But then hopefully I'm going to show you some of the results of that work. So I've looked at all kinds of use cases along. We started out looking at like human space flight for like long-range communication and command and control in like military applications. And then sort of 12 years ago, I really focused in on the manufacturing use case. And then I think about 10 years ago, sort of got hooked into MXD, and we've been members ever since. And so the title of my talk, Flexible Next Generation AR for Manufacturing Powered by AI. So the theme at MXD here today is AR, VR, what's today and what's tomorrow. So most of my talk will cover what's today, because I really want to show you guys like what we're doing in the factory. I've got some videos of actual deployments that we've done. I'm going to show you some real users using our tool that we've developed. And then I'm going to talk a little bit about what in the sort of the what's tomorrow camp, and that'll be the AI piece. It's going to be a little different than what the last project was with Scope and Northrop. I'm going to explain how we're using AI to sort of dynamically generate some content to guide a mechanic to pay attention to certain areas based on sensor data. So talk a little bit about that. That's something we're working on at the moment. The word flexible is in the title. I'm really going to keep coming back to that. I think is very important. So our platform, BARC, the Boeing AR kit, is very flexible, and it can be deployed in different use cases and different form factors using different pieces of technology. And we've done that on purpose because we need to support a lot of different use cases in the factory. A lot of different programs, a lot of different users. So you'll see I'm going to sort of highlight how we've been able to do all that with one system. And finally, my title is Technical Fellow. So I'm going to get a little bit, I can't help myself. I'm going to get a little bit technical. Going to give you guys a peek under the hood of how BARC works in some instances. I'm going to show one back-end architecture chart. I'm just going to show one workflow and show how that works. Because I think it's important to cover how to scale these things. There's a big difference between creating a demonstration of an AR system, say a HoloLens application, versus integrating this technology into a production system at the company the size of Boeing. So I want to just address that topic a little bit as well. So with that, I want to start off with a sort of an overview of how BARC has been deployed and where it's being developed within the company. My aim's not good enough for that one, so I'll just point over here, but I'm sorry for the people over there. Our team is all based in Southern California. We have, or most of the team, we have 5 of us in California, including myself. We're in Huntington Beach. And then we have 2 people on the development team actually over in Korea, in Seoul. Boeing has a engineering office over there in Korea. So we're the core team. We're the software team that's building the app and the back end that supports it. And then we get quite a lot of software support from the IT teams around the company, mostly in the Puget Sound area and Charleston. That would be all sort of things like managing the mobile devices and data types, getting data to devices, those kind of things. They support us there. And we do a little bit of work with the Advanced Manufacturing Research Center. That's in Sheffield in the UK. So they're actually working with us on a cross-platform, or some considerations, I should say, for cross-platform AR experiences. So like consistent user interfaces on devices that have controllers versus don't. Some have gestures, some have keyboards, some are handheld phones, tablets, all those kind of things. So they're helping us understand the requirements and best practices with regard to different platforms. I'll explain that a little more. And then the green boxes are really the deployments we've worked on. They're all within Boeing. There's one not within Boeing. Most of them are within Boeing. It's mainly for our own factory improvement. So we've got lots of use cases up in the Puget Sound area. Many of the commercial programs are assembled up in the Seattle area. We've got quite a few in St. Louis, and the defense manufacturing is in St. Louis. Quite a few in Philadelphia, Charleston, where the 787 is built. I don't know if anyone's been down to I should ask, has anyone been to a Boeing factory? They do public tours and things. Oh, great. So yeah, quite a few people. So Charleston, and then we do a little bit of work with the government in Pascagoula, a research project there, some Michoud, Louisiana, San Antonio, where we do retrofit of aircraft. Even down in Melbourne, Australia, I got to go to Melbourne last year. We've got a BARC instance in the Boeing factory in Melbourne where we make commercial parts, but also parts for the Australian government. and then also in Bangalore in India. That's the Boeing use case in a lab over there. So I find it really awesome to be working on this because I've gotten so much exposure throughout the whole Boeing company, commercial and defense, and the whole team really have. So it's been a really great experience. So I'm going to jump into some use cases. So this first one, this is a wiring use case. So this is on a rack in our lab. We use this for testing our system, and it's a real wiring section from an aircraft. And you can see pretty complicated wiring, and if you had to install some of that wiring on that rack, you would have a hard time doing it if you were following a paper instruction. So some of the features here, that's the user interface. You'll see more of that. We can turn on a feature called callouts. So what that does is this is from a HoloLens, wherever the gaze cursor is hitting one of the wire bundles, it's showing you the wires that are within that bundle. So that could be very useful if you were trying to track, trace a wire throughout an aircraft or a section. Couple of other features, you can isolate particular wires. So if you see on the right-hand side, some of them have the word BOM, bill of materials, after them. So those are the wires that, for this particular installation plan, have to be installed. So there's usually only a couple per IP, we call it an IP. That would be about 2 hours worth of work, so it might be 2 or 3 wires that would be installed. So you can actually understand for your job that you're doing which wires you have to install on that whole section. There's a few features that I didn't capture in the video. If you see these little things here, this red flag note and these white things, they all have metadata behind them, so that might be linked to a spec, or it might be an ME-authored work instruction or some other relevant piece of information for that location. Those are all available within Bark. You can click on it and a little window will pop up and it'll show you the link to the spec or anything like that. But the main sort of point here is we had to aggregate data from about 10 different systems to create this view. And those would have been systems that an electrician would have had to go to on a computer to log in separately, to all of those things to understand the task. And we have built a pipeline from those 10 systems all the way through. We use Unity in this case. I'll get into that in just a moment. All the way through to an AR experience. So we can now pull. There's probably thousands or tens of thousands of these drawings across the commercial fleet. We can now view any of them in an AR scene within a few minutes. So that's what I mean when I talk about the scalability of this. It's very important not to get stuck in what I call pilot purgatory. And it's a whole world difference to actually do this versus a standalone sort of demo. This is the bracket use case I was mentioning. So this has become a really big deal. Basically, we've just imported the geometry for this configuration of brackets. Person uses a HoloLens in this use case. This one is in production. We've actually got an IP and installation plan written that requires them to go check out a HoloLens, put it on, log into Bark, and do a visual sweep of this part. This is a wing spar. Do a visual sweep, make sure all those brackets are in the right place. And they cannot move on until they've done that and they've agreed that per the HoloLens view, everything is in the right place. Now, the issue here is this particular program has, I think, hundreds of variations. Airlines can order them differently, different minor models. So these brackets might be different on every aircraft. So it's not a case of once you've done one, you can do them all, because they keep changing. So that's why we did this. And again, Bark has the ability to pull in the exact configuration for that exact line number. Because we're not doing anything manually, it's actually pulling from the source engineering design every single time. So that's become a really big use case for us. Okay, so let's talk about why we're investing in all this, which obviously we're investing quite heavily, and we have been for years. We've really identified these 4 effects, and we've talked a lot about some of them. So we're really honed in, really focused on the reduction in errors and the reduction in assembly time. Training requirements is great. We can train people in the basic skills and sort of supplement that with AR. That's great. We know that AR helps increase people's retention of instructions. That's also great. But these two, the time and the errors are really where where we're really sort of laser focused. And I think, Lightguide shared some data before. I know Scope has looked at this. Many people have looked at these numbers. We did a study in the factory where we did over 2,000 hours worth of usage from mechanics using a HoloLens, and it was to install wiring, very similar to the first video that I showed. And then we had the same people, the same wires, it was the same aircraft, exactly the same jobs on airplanes before the HoloLens and then airplanes with the HoloLens. And we did it over 6 airplanes. And we looked at the time to complete each job and the number of mistakes made, and we saw the number of errors went down by 80%, and the time to build went down by 80%. So those things are huge, right? Combined together, you might think if you were trying to reduce errors, you would have to go slower. But in this case, we can drastically reduce errors, but we can also go faster. So I know I'm preaching to the choir here, but I wanted to show this data point as well as one more thing that we're trying to realize. We recognize the need for a hands-free solution. Not that everyone wants to wear a headset, and many people don't. And so sometimes I think Paul did a great job this morning about the pros and cons of each type of way of delivering AR. But we really want to be as agnostic as we can, so we can just let users decide what works for them. And Bark is actually built that way. You can just view the same data set on different devices. Okay, so here's the sort of the top-level view. So as I said, we don't create any new content. We just work to reuse existing content. So we've got several interfaces to different Boeing PLM systems. Anyone that's worked with Boeing will know we use different systems for different programs. There's sort of little consistency between the way different programs do things. So a lot of what we do, a lot of our time is figuring out the data source. How do we get to it? Is there an API? What structure is it in? What format? And can we convert it to something that we can use in our system? So these blue arrows at the top here, this is where we spend a lot of our time. Bark Services is the back end. So that's all hosted in Boeing's internal cloud infrastructure. It's many different services doing different things, but it's a collection of things. It extracts data from repositories, it converts it, it can deliver it to a particular user based on user logins. I'm going to show you some components to Bark Services. Basically, it's sort of the brains of it all. And then the application itself here, we also write the code there. It's in Unity, as I mentioned, can be installed on different devices. And Bark Services has this web UI, this website that I'm going to get into, show you some more detail next. And then I mentioned some of the use cases we've talked about, wiring, locating these features. You can't quite see on this, maybe you can see, but there's these color-coded icons here. These are MBIs. The Siemens folks would know that as a session file from Viz Mockup. We've developed a pipeline to bring in Siemens session files into Bark. Verification of brackets, I showed you the one on the wing. Paint decals, all the maintenance markings on the outside of an aircraft. We've got pipelines to pull all those into Bark. So we've got lots of different use cases, all supported by the same framework. Okay, so talk a little bit about the UI. So much of the whole process is the same regardless of the use case. So whether you're doing wires or holes or fasteners, the way to get data, the way to use Bark is the same. So all of these sections, these three are all consistent. The only part that changes is what's in the red box on the top right. And that is to account for the variability between programs and the data types that we're working with. So this particular use case, the screenshot is actually from that brackets use case. So they would enter what's called a customer variable number, a CVN number. That's just a 6-digit number that describes that aircraft. We use it internally, that exact configuration. So by entering that CVN, they can then click the generate button. That will kick off this whole automated process to go get the models from the repository, convert them, get them into Unity, stage them, and deliver them. Well, I'll explain that more on the next chart. Other use cases, wiring, this group here, just enter a drawing number, and whatever drawing number they enter, they get to see on the HoloLens or the iPad. There's teams using it for all kinds of stuff. This one, the group in Seattle using it in a wind tunnel. I don't exactly know what they're doing, but they are uploading their own CATIA files, I guess experimental designs. They're viewing on a HoloLens inside of a wind tunnel. And then for MBIs, you would enter the MBI number and the ship number, and then you can pull in an MBI. So just different use cases, all supported by the same process flow. And this is that one chart that I mentioned at the start. I'm not going to go through all of this, but I did just want to show some of the detail here of what it takes to make this a reality. So I'll just walk through start to finish just one use case. So users come over here. I'm sorry again for the people on that side, but to the website, and they would enter a request, some sort of, I need to view this data set. So you would do that through the website. That request, we call this piece here the app tile, so this can be replicated very quickly, and each program gets their own app tile. So, and that's what all these are here. These are just replications of the same thing, and we have probably 30 or 40 of these deployed now to support different use cases. So when a user enters a request for a job, this workflow engine, this workflow service here is really the heart of the operation. Everything is orchestrated here, and it allows us to build new workflows for new use cases with different data types and data sources. So in the case of those brackets, the workflow engine would actually communicate with this service up here. This IVT is the integrated visualization tool. It's a Boeing tool. So it would say to IVT geometry service, I need some geometry for this line number, this aircraft. This service here would pull the geometry out of the IVT repository. Then it would say, OK, here's your geometry. The workflow service would then convert it. We use Pixies, the SDK, to convert between file formats, so it would convert it to something more lightweight. Then it would send it to what we call the bundle builder, which is Unity running on a VM. It's a scripted version of Unity that just imports all the assets and makes a bundle out of it. And then when that's done, the workflow service will place it in storage in this S3 bucket, and then it's ready to be viewed. Now, when the user wants to view it, they go back to the website and they scan a QR code, and then our delivery service takes that data set from storage and then pushes it over Wi-Fi to that device. So I know that's a lot to take in, but I did just want to sort of give you one sort of run through of how we link the source CAD to, say, a HoloLens end to end. Few more shots of the website. So when you enter a job request, you can track its progress. So you can see when it's ready, and you can track it through where it's being converted or what stage of the process it's in. And that's on this tab here. And then here's that QR code. So when you scan this, it's going to deliver all the jobs that are assigned to you, to your device, whatever device it might be. Now, the one thing to note here is this QR code, there's a timer here. It lasts for 60 seconds. So there is a security token embedded in here. And to get to this website, you have to use your Boeing secure badge and your PIN. It's like standard single sign-on stuff. So once you log in, it generates the QR code, and you have to scan it within 60 seconds. When you scan it, the device decrypts that security token, sends it back where it validates that it's good and it's within 60 seconds, and then it will allow you to view that data on the device. The reason we do that is to prevent people from printing these out, leaving them lying around where perhaps people could get them who don't have access to that sort of data. And then, I know I said there'd only be one complicated chart, but I guess there's two. This one is a view of the front-end application. I won't go into too much detail. The main takeaway from here is that the application that runs is componentized. And we did that so that we can easily add new features in the future that maybe we don't know of yet or haven't supported yet. So a lot of the components are the same across all the use cases, like logging in, the safety part. There's certain common, consistent themes. But then depending on the use case, sometimes you're displaying callouts, or sometimes you're doing an AI inspection. Those would all be components that are loaded specific for that use case. And again, I've mentioned this single code base can be deployed on different devices. I'll just talk briefly about alignment. I'm just going to speed up a bit because we lost a bit of time. How we align in the aircraft, so we've already talked about accuracy. So we've got several methods of aligning. And just so we're on the same page, when I say alignment, I mean if you're viewing an AR scene, the error between the virtual content and the real world, how accurately can we get that? So we have a few different ways of doing it. The first one was this, we call it the wand. It's just a 3D printed tool. It's a Vuforia marker there, and you just touch predefined points of the aircraft using it, which is all set up through the website. Users configure their own alignment points on the website. And then when you touch 3 of them, pretty straightforward, we make a coordinate frame, and now we understand how the device relates to the aircraft. Similar concepts, some teams are designing these 3D printed holders just to basically mount markers, sort of old school, but still really reliable and repeatable, and is easy to do for someone. So most people, I would say, are still using markers. It's here, they've slotted them in holes, it clips in this bracket, whatever they want to do. And using these approaches, we can get, it's about 0.2, 0.3 inches, but of course it's a little bit dynamic, and it's not something you can really sort of rely on all the time. And then more recently, we've been working with PTC model targets. So that was that one video I showed to begin with. So we've integrated their model target generator using a command line interface on the back end of Bark. So you can upload a small model and say, hey, I just want to recognize this water bottle or whatever and use that for alignment. And we've just deployed that. And so more and more people are sort of slowly moving over to using aircraft parts instead of markers for doing alignment. OK, just a couple more slides. So now onto the AI piece. So what we really want to get to is, in the case of verification of brackets, for instance, have AI tell us whether brackets are in the right place or not. So we have an internal AI organization at Boeing, and we've been working with that team. They've been working on these object detection models for particular parts of interest. So these brackets are a little different than the ones I showed earlier, but they would go out and collect data, basically take a bunch of pictures of that bracket, that part, and they would train an object detection model on how to recognize that in the future, given some imagery of it. So we have a concept where we're going to have a repository of these object detection models, and depending on the use case with Bark, if you want to do an inspection, you'll check a box, and then it will go get the object detection model for the pieces you're trying to find, and then it will, as you're removing a HoloLens or an iPad or something, it will actually be able to find those parts real time in the image. This is how that will integrate, we think. This is what we're currently working on today. We're going to go through the rest of this year working on this. So here's that repository here. It's going to have all the pre-trained models of what parts look like, basically. The classifier is going to run on the mobile device. Right now, we're using CoreML, so it's limited to iOS devices. So on the Bark website, if you select, I'm going to do an inspection, it's going to gray out the HoloLens. You're not going to be able to do this on the HoloLens currently. It's going to be only iOS. And then in this wing use case, the goal is, right, we know where all these brackets should be because we have the BOM, we have the engineering design. So we're just going to take a little crop of where we think each one should be, run it through that classifier that's been trained on what it looks like, and then it will return a confidence level of whether it's actually there or not. And we'll set a threshold. So we'll say, OK, if it's less than 90%, we're just going to flag it, say it's potentially not there. And then the operator will just get this little, that's just mocked up, but they'll get some sort of indication, hey, there should be a bracket here. Our object detection didn't find it. You go double check that it's actually there. So we're trying to get to the point where you would do a visual sweep, and it would just direct the operator to exactly where they need to pay attention because there's maybe a missing part. So I know that was a lot. That was my last slide. I know that was a lot in 30 minutes, and I wanted to give you guys as much detail as I could at the same time as showing you the breadth of everything we've done. So thank you for your attention. Happy to take questions, comments, whatever we're doing next.
Yeah, let's take we got a few questions. Yeah, thanks, Paul.
Paul, is your main AR use case always with internal employees, or is it also for outside, or just always internal?
Almost always internal. We develop this for our own consumption. I always say Boeing factory, Boeing data, Boeing people, Boeing product. So if those four things, then yes, we would do this. We've started to branch out a little bit. We're working with some other folks. We've gotten a lot of interest in this from outside of Boeing, so we're sort of still investigating how we might deploy it, use it in other industries, but that's early days. So, yeah, almost all internally at the moment. Yeah.
Thank you.
Yeah.
How are you stripping back CAD so it can work in the HoloLens enough? Like the size of CAD sometimes can be bulky and hard to use.
Yeah. So it's a good point. In the Pixies SDK box in the back-end view, we can actually set the level of tessellation there. So we have a limit. On the HoloLens, we limit it to about 750,000 polygons, which is really pushing it. It's still a bit sort of jerky at that rate. But any more than that, and it doesn't, the job, we've set it so that it won't complete, and it'll notify the user that you can't, that's too big.
So essentially that software is just scaling back the mesh to
exactly.
Okay, perfect.
Yeah.
I would say the theme to most of what you showed was quality control use cases. Would that be the primary value you're getting out of Bark, or is it all over the process?
Yeah, no, it's quality. I mean, not much else to say. I mean, we're trying to get people, to reliably produce the same thing over and over again. We know this can do it, right? This technology, many of us has proven that it can almost solve the quality challenge entirely. The problem is how do you scale it and devices, that kind of thing. But yeah, quality is number one. So the question was, is Bark a content management system where people can build experiences? I think I wouldn't call it content management. It's a system to retrieve existing content out of PLM or other repositories, but it's in such a way where users can configure that and deploy it on an AR experience. So we don't store any content within Bark. We don't want to replicate, the PLM or the repository that has the authoritative data. We focus on just automated pipelines to get it out. And then once you're done viewing it, if you want to see it again, you have to go get it again, because that always makes sure you get the latest source-controlled engineering. So.
Oh, I was just going to. When you've shown a couple different hardware ways to visualize it.
Yes.
When you make that decision on hardware trades, what is your thought process behind that kind of expansion process into a new medium?
You mean like the hardware being used to
going from a HoloLens to an iPad?
Yeah. So our approach is to be as hardware agnostic as we can be. Obviously, there's some sort of technical limitations to that, and so when we first started Bark, it was like in 2016. We were just all on the HoloLens 1, and it was we just wrote an app, and it only ran on the HoloLens 1. And then when when Microsoft sunset that, and they came out with the HoloLens 2, of course we had to start again. And then it was all dependent on the mixed reality toolkit. And so just last year, we actually had a big effort to strip away any dependency from our code from the HoloLens. So now we use the Unity XR Interaction Toolkit, and it's built on OpenXR, so we can actually deploy our single code base. Right now we support HoloLenses, iPads, and iPhones. Real soon, I think maybe even as soon as like next week or the week after, we'll have Android phones and tablets. And then we're going to do a Magic Leap, but Boeing only has like a few Magic Leaps, so I don't think that's going to be a big thing for us. Scott's giving me this look over here. He's like, "What the heck?" But no, but I really wanted to do the Magic Leap just to sort of convince myself that it is truly platform agnostic. I don't think we're actually going to be implementing Magic Leap. So.
What would you point to as the greatest single use case in terms of business value generation that's come out of Bark?
Oh, that's a tough one. So. I would say that the use case we've gotten the most value out of is something along the lines of this one, because it's so simple and we've done so much of it. Just locating a feature like a fastener or a hole, bracket, a paint decal or something where you don't even necessarily need CAD. You just need to know the XYZ location of something. That's really easy to do, and we've probably done that 15, 20 times on different use cases. So we've probably gotten the most value out of this one. But out of a single use case, I would say the wiring is probably one, but we've done much less of that, because it's just more complicated, it's harder to pull off, but yeah.
You're mentioning the different kinds of hardware you're trying. I'm just curious, as you think about next steps, is the Vision Pro anywhere in your radar?
Probably not for us. So our team, we focus on the factory. For sure, Vision Pro, outside of the use case, outside of the factory in office areas, whatever. But I just don't think it's feasible in a factory. It's video pass through. It sort of occludes your vision. I just think. Although it looks very good, I just don't think it would be practical to really do something with your hands using it when it's sort of. So, we haven't tried it, but it's not really a focus of ours for the factory. Yeah, but I'd be interested if anyone else has different opinions on that, because there is no great solution for a headset. I mean, we all know Microsoft is winding down on the HoloLens, and there is a bit of a gap there. So, yeah.
Yeah, you run an R&D center, and you've created what appears to be quite an enterprise piece of software here. How have you transitioned that to managing it to make it stable for operations and still being able to focus on R&D?
That's a great question. I would like to get more support from IT to really take over the ownership and running this in the factory, but I won't sort of go into the detail. I won't vent too much. But basically, it's our team. So we are actually balancing between, our team takes the calls when things have issues in the factory for Bark, and we also have to balance that with the development. So, it's really hard. We keep a backlog. We use ADO, Azure DevOps, and so we do have like different levels of priority of people calling with things not working or whatever. And then we've got our development tasks, and every week we just try to prioritize what's top priority for that week. Yeah, but ideally we would separate those. Yeah, it's been a struggle.
So since you talk about the alignment there, what's the tolerance level that you found is possible with this?
Yeah, we've done a lot of work on that, actually, a lot of research. so far as we've set up a motion capture system inside of an aircraft, and we wrote an app that, we pick points and it measures the distance that we think it is from the ground truth from the motion capture. About 0.2, on a HoloLens, about 0.2 inches is what we found inside of an aircraft, which is a pretty nice environment for HoloLens because you've got lots to track off of. iPad, we haven't done it, so we don't know what the iPad would be.
I'm curious, you're checking the whole locations at that point in the process. I mean, like, number one, how could it be off at that point? It's like, it's on 20. I don't understand, like, how could it be off?
So
if it is, like, how do you correct it? It's already on 20.
It can definitely be off. So that part comes from a supplier, and so we've had instances where we go and we take a floorboard, we try to put it in, there's a hole missing. That's easy, we just drill it, right? But we want to know that ahead of time so it doesn't hold up the line, and so it's all about when we discover it. None of these things are big issues, it's just when you find them. I'm going to show some examples of bigger issues like bracket detection, whereas if we don't find them right up front and we find them when we're trying to put in like the stow bins, say in 3 or 4 days later, and there's a bracket missing, and then you have to remove a whole bunch of stuff and all the blankets to get to it, that becomes really expensive.
Great. I think we have time for one more. Yep.
Yeah, are you running any kind of machine learning in the process in the background while you're making all the work process tracking?
No, machine learning for which?
Just say, for example, if there was any issue that was constantly being occurring. So to overcome those things, are you running any kind of machine learning?
Not at the moment. I mean, that's a great use case, and I think eventually we'll get there. But yeah, not just yet. Yeah.
Great, thank you.